Okay, we are moving on to probability 7-3. This is independent and dependent events. Independent events are two or more events that do not affect the probability of each other. So if I say, what's probably flipping, getting heads on this quarter, well, this penny is totally independent of this quarter, so it's not affected by this guy. So what's the probability of getting a heads on this? It doesn't really matter what I got here. They are totally independent of each other. Dependent events are ones that affect each other. So if I say, what's the probability of flipping these two coins and getting both heads? Well, if I flip this guy and it's a tails, well, there's no way, no matter what I flip on the penny, it's game over. So it does affect the total outcome because they are dependent on each other to both be tails, or if you are rolling dice, what's the probability of getting 2 6s in a row? One event affects the other, the probability of it. Conditional probability is the probability that event B occurs given that event A already has occurred. And they kind of denote that with probability BA. So it's like that previous example, what's the probability of getting 2 heads? Well, if I've already flipped event A and it's already heads, what's the probability of this getting a heads to match up with double heads? That's a conditional probability. That the fact that you already have one of the results, what's the probability of putting it together with the second one and getting 2 heads? That is a conditional probability. Okay, when the probability events are totally independent, you just simply multiply. With dependent events, this one you are going to multiply, but you'll notice the results of it occurring are much harder because 2 things have to happen. I mean, this has to happen and this guy has to happen. Let's take a look-see at this table and go over an example here. The table shows students participating in different events at a high school. Suppose that a student is selected at random. Okay, so we've got track, volleyball, basketball, tennis, no sports. We've got grade 9 through 12, and here's the total people doing track and volleyball and the total number in the entire school. What is the probability that a student is grade 10, so P10? So you're just randomly picking, and how many 10th graders there are? There's 135, so that probability is 135 out of the total for the entire school, which is 440. So what's the probability if you're just picking a person and he is a sophomore, he or she is a sophomore? It's 30.7%. Part B, find the probability that a student runs track given that the student is in 10th grade. So you already know that we've got a 10th grader. So basically you're saying here, we're not even worried about these 9th graders. We're not even worried about these 11th and 12th graders. We're just focused on all of these 10th graders. So that's a conditional probability. What's the probability that they run track? Well, how many 10th graders run track? 6 out of the total outcome of 10th graders is 135. Not the entire school, because we are given that the student was already in 10th grade. So we knew they were in 10th grade. Only 6 10th graders out of 135 total do track, and 6 divided by 135 is approximately 4.4%. Find the probability that a student is in 10th grade and runs track. So 2 things have to happen, and these are dependent on each other. First of all, you got to figure out the probability that you're in 10th grade. So it's 135 out of 135 out of 440. And then you've got to find the probability that they are also doing track 10th grade. So it is 6 out of 135. And with these dependent results, we are going to be multiplying. So first you've got to pass the fact that you've got to pick a 10th grader. And then from the 10th graders, you've got to pick the fact that we have a 10th grader who's doing track. This is just, that's top times top is 810. This is 59,400. So the approximate chance of this occurring, that you pick a sophomore that is a sophomore doing track, is about 1% chance out of the whole entire school. Okay. Finally, find the probability that a student runs track or plays tennis. Given, so this is a condition, we already know they are in 12th grade. So that means you don't need to worry about the 9th graders, 11th graders, 10th graders here. Everything revolves around these 85 12th graders. What's the probability that they do track or tennis? Well, how many 12th graders do track? 7. How many do tennis? 12. And you put that over the total of seniors, 12th graders, 85. So this is really 19 divided by 85, or approximately 22.4%. Okay, so you just got to read these questions carefully.